application questions, okay, that we will need to solve when it comes to integration, right? But before that, okay, just a very quick summary about integration and differentiation. Okay, we know that when we're given a function in y, we differentiate to get our dy over dx. And our dy over dx is very often interpreted as gradient of a tangent in the curve. Okay, then if we were to do the reverse, okay, from dy over dx to y, that is where we're trying to do integration. So we're making use of the gradient that we're given to find out, okay, what is the curve, the equation of the curve or equation of the line, whatever that we're given. Okay, that is what we're going to be looking at when we see try 7. That's in your textbook, page 100. Okay, so in this question itself, it says that the gradient of the curve at any point is given by dy over dx equals to 2x minus 1 cubed. So this is a critical piece of information. And then the curve cuts the y-axis at 0, 3. So we want to find the equation of the curve. So if you want to understand integration as a reverse of differentiation, that means that I need to do an integration to this in order to find out what is the equation of the curve. Okay, so if we were to integrate your 2x minus 1 cubed, based on what we know so far, we will keep the 2x minus 1 cubed, but we change the power to a 4, and then we divide by 4 and multiply by 2. Okay, so this means that we are getting 2x minus 1. Oops, we have forgot something. We got a plus c. Okay, so we are going to be getting 2x minus 1 to the power of 4 over 8 plus c. Okay, but this is not the exact curve equation for this particular context, because there's more information that's given to us, which is that the curve cuts the y-axis at 0, 3. Okay, so this piece of information that we're given will help us to find out what is the exact curve equation. In other words, the exact value of c, okay, for this particular question. Okay, so since you're given that it cuts the y-axis at this point, that means that y is equals to 3 when x is equals to 0. So we replace the coordinates accordingly, and that will help us to find out what is the value of c. So this will give us 1 over 8. And we find that c is equals to 2 and 7 over 8. And therefore, the equation of the curve will be given by y equals to 2x minus 1 to the power of 4 over 8 plus 2 and 7 over 8. Any questions at this juncture? Right, next we look at try 8. Okay. In try 8, right, we're given that the second derivative is equals to 6x plus 12, and there are 2 points, 1, 5 and negative 1, 11. Okay, we want to find the equation of the curve. So take note that we're not given dy over dx, we're given the second derivative. Okay, so that means we need to do 2 rounds of integration before we arrive at the equation of the curve itself. Okay, so when I integrate the second derivative, what we are going to get is our dy over dx. So we will have 6x squared over 2 plus 12x plus c. Okay, so our dy over dx will be 3x squared plus 12x plus c. Okay. Then, right, okay, we will do a second round of integration in order to find out what is y. So we will integrate 3x squared plus 12x plus c. Okay, so integrating c will give us cx, and not forgetting that when we integrate, we will get d. So our y will be x cubed plus 6x squared plus cx plus d. Okay? But this is not the exact equation for this particular context. In this particular context, the question says that there are 2 points on the curve. One is 1, 5, the other one is negative 1, 11. So we need to make use of that information by substituting it accordingly into this equation over here, so that we can find out what is the value of c and what's the value of d. Okay. So for the first point 1, 5, we'll find that y is equals to 5. Which gives us on the right side 1 plus 6 plus c plus e. So c plus d is negative 2. We do the same thing for the second point. Here we get 6 equals to negative c plus d. Completely up to you whether how you want to solve this pair of simultaneous equation. Either do by substitution method or elimination method. Okay. So if I do by elimination, I can eliminate away the d. Okay. So that will mean that we have to rewrite this. Then we can find c equals to 4. Negative 2 minus 6. C equals to negative 4. And then we find that d equals to 2. And therefore, we get the equation. Okay. Y equals to x cubed plus 6x squared minus 4x plus 2. Give me just a minute to digest, huh? recall one thing. Okay, in case you're thinking of dy over dx as gradient all the time, which is not wrong. Okay, I did mention that dy over dx is supposed to be gradient. It is supposed to be gradient of a tangent. Okay, so we need to be very clear about that. Okay, because I don't want you to fall into this problem of thinking of gradient of a straight line. Okay, gradient of straight line doesn't always mean gradient of tangent. Okay, because I don't want us to think that I can take these 2 points and then apply my gradient formula. Okay, it shouldn't be a case whereby you take these 2 points, apply a gradient formula, and then after that substitute inside here to find out what is the gradient. Okay, why? The reason is because in this particular curve, okay, it is just one point that is 1, 5, and then another point that is negative 1, 11. Sorry, maybe to be more accurate. Okay, never mind. Just random 2 points up. Okay, it's not accurate at all. Okay, there are just 2 points on the curve. If let's say you want to find the gradient using this formula, what are you trying to find? You are trying to find the gradient of this line segment over here. Okay, by connecting the 2 points together. This line segment itself is not a tangent at all. Agree? Visually you can see that, right? Okay, so don't think about taking these 2 points, apply this, and then equal to this dy over dx. That's not true at all. Okay, this dy over dx is supposed to be gradient of tangent. Okay, not any other straight line. Right? So which explains why, okay, we must actually do our integration again, find out what is the equation of the curve, and then after that substitute in the 2 points, okay, because these 2 points are on the curve itself. Alright, then after that it will help us to find out what is the value of C and what's the value of D, okay, so that we can eventually find out what is the equation of the curve. Okay, so I want us to be very clear about this. Do not think about trying to do this. Okay, questions? Okay, if not, I want you to give this question a try. Okay, that's in your exercise 16.1. Question 16. Okay, I just want you to do part I first. Similar process, try to find out what is the equation of the curve, and then use the information that the minimum point is at 1, 5. Okay, what do you think you can do with this information about minimum point at 1, 5? Okay, I'll give you about 5 minutes to work on it, right? see that most of you are able to integrate, okay? But whether you can proceed from there by making use of this point is another challenge. Okay, so given the second derivative, I can find out what is dy over dx by integrating the 6x minus 4. Okay, so integrating 6x minus 4, you will get 6x squared over 2 minus away 4x and not forgetting the plus c. Okay, and then this simplifies to 3x squared minus 4x plus c. Right? Then most of you know that we are trying to find out what is the equation of the curve, so we need to integrate this again. Okay, so integrating this again will help us to get our y. So 3x squared minus 4x plus c dx, and then we will get 3x cubed over 3 minus 4x squared over 2 plus cx plus d. Okay, simplifying this, we get x cubed minus 2x squared plus cx plus d. Right? So now minimally we should all be able to do this. Okay? Then how do we make use of the fact that the minimum point is at 1, 5? Okay? So earlier on with the example that I've shown you, likely you will use the 1, 5 first. Okay, so at 1, 5, substituting it into this equation here, where y is 5 and x is all 1. We will have 1 minus 2 plus c plus d. So c plus d is equals to 5 plus 1, that is equals to 6. Okay, we're trying to find out the value of c and d, and that is two unknowns. Whenever we have two unknowns, we need two equations in order to solve. Okay, that's why we need to do simultaneous equation. But then in this case, we are only given one pair of coordinates, unlike the earlier question where we are given two. Okay, so where is the other information going to come from? How are we supposed to create, okay, the second equation? We have not yet addressed this thing about the minimum point. Okay, so when it comes to minimum point, we are aware that maximum or minimum, your dy over dx is always equals to 0. Right? Okay, so at 1, 5, also, we are aware that dy over dx must be equals to 0 because it is a minimum point, it is a stationary point. Okay, so that means that dy over dx must be equals to 0 when x is equals to 1. Okay, so we are making use of this part over here, whereby dy over dx equals to 0, x equals to 1. Okay, so we have 3 minus 4 plus c, and hence our c equals to 1 itself. Okay, so that's how we can find out our c equals to 1, which then helps us to find out what is d. So d equals to 5, and then we can answer the question where c is 1 and d equals to 5. So y equals to x cubed minus 2x squared plus x plus 5. Okay, so in this curve itself, apparently from the question in part 2, it doesn't just have a minimum point, it also has a maximum. We want to find the maximum value of y. Okay, so since we already have y equals to x cubed minus 2x squared plus x plus 5, okay, where we have the value of c and d, we also know that dy over dx, replacing the c, will help us to get what is dy over dx, okay, itself. So our dy over dx is actually 3x squared minus 4x plus 1. Okay, and be it whether minimum or maximum, it is a stationary point. Your dy over dx is equals to 0. Okay, so this goes back to our differentiation, whereby we make use of dy over dx equals to 0, and then we are solving a quadratic equation. In this quadratic equation, we can factorize it, and we will have 3x minus 1 times x minus 1 equals to 0. Okay? Really want to emphasize over here the importance of writing down this step if you're doing your factorization. Your factorization must be consistent with the fact that whatever equation that you have over here. Okay? Don't always try to use calculator. Alright? Please make sure you know how to do factorization itself. Okay? Otherwise, you can always use your general formula also. Okay, the x equals to minus b plus minus square root b squared minus 4ac that one. Okay, so x equals to 1/3 or x equals to 1. We know that it cannot be x equals to 1 because we know already when x equals to 1, it is a minimum point. Right? So naturally, we can reject away x equals to 1 and use x equals to 1/3. But we are not certain that x equals to 1/3 is really going to give us maximum value. We need to actually prove it by making use of our second derivative tests. Okay, so your second derivative has been given over here. Okay, your second derivative is already given in the question by replacing the x with 1/3. We find that it will be a negative value, okay, of negative 2. Hence, it is a maximum at x equals to 1/3. But then the question wants you to find the maximum value of y. So, you need to figure out what is the y equals to first. That will be equals to 1/3 cubed minus 2 and 1/3 squared plus 1/3 plus 5. Making use of what? Of your y equation. That will give you 5 and 4 over 27. Okay. So therefore, maximum y equals to 5 and 4 over 27. One last question before we call it a day. So looking at question 20, we are given that water is being pumped at a constant rate of 2 cm cubed per second. So with this particular information, okay, we know that our dV over dt is actually equals to 2. Okay? Then after that, the question also mentioned that the volume is equals to 150 cm cubed after 10 seconds. Right? Let's look at the very first part of the question. It says that find an expression for the volume of sphere in terms of T. Okay, we know the volume of a sphere in terms of R, which is V equals to 4 over 3 pi R cubed. Okay, but then this information is not helpful for us to find out what is the volume in terms of T, because we don't have any information about radius at all given in the question. Okay, so the problem here is how then do we solve this question to determine the volume. Okay, we are actually given that volume, the rate of change of volume is actually equals to 2. In other words, dV over dt equals to 2. And if you understand, okay, this idea over here, alright, I can find out, okay, what is y, or in this case v, by doing my integration. Okay, when I do my integration, I'm integrating respect to x in this case. But over here, when I do my integration, I will integrate with respect to t because this is dv over dt. Okay? So when I integrate the 2 itself, it is just a constant number. We will get 2t, and not forgetting plus c. Okay? And that will be how we find out what is the volume in terms of t. But that is not all, because we have a value of c. Okay? So we must find out what is the value of c, and that is by making use of this information, whereby the volume v is 150. After 10 seconds, that means t equals to 10. So volume 150, t equals to 10, and that will help us to find out what is the value of c. So volume is equals to 2t plus 150. Questions? Then in part 2, we want to find the radius of the sphere after 2 seconds. Okay, that means that with this formula where v equals to 2t plus 130, okay, I can find out what is the volume after 2 seconds. Which is 134. Okay, and since we're talking about a sphere, we earlier on mentioned that v is equals to 4 over 3 pi r cubed. And now since we know the volume itself, which is 134, we can find out what is the value of r. Then it's a matter of your calculator give you the 3SF answer of 3.17. For part 3 and part 4, since our time is up, okay, we'll end here for today. Tomorrow we'll finish that up. Okay, so tomorrow we will finish up part 3 and part 4, then we move on to our trigo integration. Okay.